Are we live? I guess we are live. Hmm. Hmm. Yep, I think we are. Nice. So, let's start. Okay, I would like to see this music one more time. Yep. Okay, what's the goal? Hmm. We are going to fix the splits and slices all the way, right? I think we have fixed iterators, so I will not worry about iterators now, right? Hmm. Okay. So, what is going to be my uh, way of doing it? Uh, so, for every, I think there are more, there are some shrinking algorithms, there are some popping algorithms, and there are, right? So, that's there. And I think all these algorithms are going to be fun to write, and I'll try writing all these algorithms. So yeah. So let's see. These are the base algorithms, right? Split algorithms, I think I will come to it later. So I think I will turn on screen key. Right. So what are these algorithms? These are trimming algorithms, like, right? Uh, Let me start with some trimming algorithms. Like one of the trimming algorithm is drop first. So let me get it here. Hmm. What's the next trimming algorithm? The next trimming algorithm, I guess, is uh, drop last. Here, the catch is whole is a bidirectional collection, right? So we can drop the last element. Hmm. And then we have, I think we do have more drop algorithms. Uh, so FN, I think those drop algorithms. Drop prefix up to and I think this should return bool, right? Hmm. So one thing I might want to do is uh, self dot uh, assert bound check slice for position, right? Um, Once we have our bound check, what I can do is I can try dropping the prefix up to right. So the prefix of slice up to given position, right? And here you do self dot from is position, okay? And similarly, you have position, and drop prefix through. Position. So what it should be. Hmm. Wait. Right. Hmm. So drop prefix through is done, and drop prefix. So we have drop prefix through. Now, I guess we might want drop prefix until, right? Hmm. So this is drop prefix up to, we might want a drop prefix method, right? Right. Drop prefix. Now let's try this one. This drop prefix. So there's so many drop methods, right? That I can actually use. So okay, so I have this drop prefix, and now let's try to solve it. I'm not sure how to solve it. So uh, let new from is self dot start and self dot okay, self dot from, right? And uh hmm, self dot uh what's this? Uh next and limited by right, and hmm, so we have from and nice. We do drop prefix. Now, how to do right? And we can do more things like drop until and things like that. Hmm, right? Or right? And all of this drop thing would have a pop uh, alternative, right? So self dot first position where, right? So it's nothing but it satisfies predicate. Hmm. Drop until predicate satisfies, right? And hmm. Should I also take like so we basically drop many things, right? We can drop uh so many things like drop first, drop last, drop prefix up to, drop prefix through, drop until. But should I have like uh take algorithm, something like that? So like algorithms like prefix, uh, suffix, things like this. Hmm. I am not quite sure. I am not quite sure here, to be honest. Uh, because we have prefix algorithm and suffix algorithm, it's just you know we are doing all this drop algorithm, so I'm not sure. Uh, And at any point, if someone wants to do anything, they can use this pop algorithm, and that would work, right? That would work. So I can rely on pop algorithms for many of the things. So yeah, I think drop algorithms are the one which are the fundamental, right? And I would uh, like working more on drop algorithms and then pop algorithms. So that should be the way. Okay. So drop, mm, suffix of uh, right, and for that I need to see how did I compute suffix, right? So for that, collection extension, uh, so where is this suffix algorithm? Yeah, this is the suffix algorithm. Right. Y7J. Hmm. Hmm. So we have drop suffix now, and drop suffix from position. Whole position. Hmm. I think examples would be really helpful here. suffix from right. I can add more and more examples for many places. Hmm. And here's the thing, like you do a lot and lot and lot of changes. Oh, I got some message from Lucian here. Let's say we have an algorithm that has two iterators and j. We can imagine an algorithm. This cannot be done positionless without requiring to start addition. If we say three slices, we cannot increase the. Yeah, that is so true. To be honest, iterators I and j. I. If we start with three slices, begin j, and in the first range so that it overlaps with the third range, making s2 a negative. Hmm. It's true. You can do this by projecting, maybe. Uh, but I do not know, right? Because with slices, currently with slice first design with slices, you're doing like we can do really great things. You might try. And yeah, we add more examples so that you know uh, we do better, right? And most of the time, I would like to do things like using the internal one itself, like using the whole thing. Nice. Let's see. If we increment I to be greater than j, then can switch the meaning of our slices. I don't have to remember somehow that we swap this position. If we extend this to general algorithm, we might need long list of swaps, and taking a list of swaps consideration might change the shape of algorithm. Might need additional lookup into the list of swapped positions. I until mm, let's see. Hmm, drop suffix. I think we are really good with our drop algorithms. Like these drop algorithms are uh, really nice ones, and I think kind of complete set, right? This is kind of complete set we want to have, and now I would try to do uh, put this to pop, right? So mm, uh, and then lazy pop can also be a thing, right? Hmm. So we have two kind. So we have two kind of pops here. One is this pop. One is lazy pop, right? So I okay, that's nice. Yeah. Yeah, but we do not know whether min is the first split point or the second split point. In this algorithm, we need to return another return is min or max. And yeah, the fact that information need to be returned from a message only problem if you cannot show that this information can always be known. Hmm. I think Lucian is right regarding min-max. I am not really happy with the current state of min-max algorithm in positionless design, but I do not have any alternative, and I think positionless design is worth exploring even after these limitations. So I would continue that. But today it's the day of rs-stl, and I'll be doing rs-stl. So yeah, we have the streaming algorithm, or I'd call dropping algorithms, right? Now, hmm, hmm, okay, splitting algorithms are fine. Shrinking Okay, if all algorithms use only one iterators or relative ordering between iterators remains, then I think we can easily prove the equivalence. Uh, yeah. Regarding min-max, yes, it's a problem, but we'll see where we can take it. Currently, the state of positionless design is okay. That I am exploring parallel algorithms. So if I say github.com rs-stl, right? Not rs-stl, sorry. It should be positionless Swift. Hmm. So what went wrong? Okay. So this is the state of positionless algorithms, right? So currently we are exploring uh, collection very differently. I don't know, like how good is this experiment, but yeah, currently it's kind of messy. We'll see where it goes. But okay. Anyways, hmm. Uh, so what do I want? I want to remove actually all of it, right? Hmm. And yeah, YSC. I don't know if that works, right? Uh, and okay, Y%, YGBP, and these are popping algorithms, pop algorithms, right? And yeah, what is this? We see we are like okay, pop first, right? And remove the first element, remove and returns the first element, right? If any. Oh, how did I encode it in my current code base? Mm, split for first if and its position if not empty returns otherwise. If okay, right. So uh yeah, I am doing a lot to bring fix this pop algorithms and drop algorithm so that uh, it is kind of a complete set, uh, and we can start using that complete set, right? Nice. So that all of these algorithms we can actually yeah, we can just actually call slices like suffix, drop. Wow, we do have drop. Wow. Hmm. Wow, we do have drop. We have drop while. I guess. Hmm. I don't know. So there is this drop until should be drop while, right? So I think drop is a kind of verb, right? Dropped, and dropped is something we might want to use for collections and for slices because drop is a verb. I'm not sure what should be the naming conventions, but I would try to follow the Swift ones because Swift API guidelines are like quite awesome to be honest. Okay, yeah, drop drop prefix up to drop while. That seems nice. Okay, so I do have error.full. Mm-mm-mm. For first, let first is s dot for first, right? Assert s dot equals this thing, and that is pop first algorithm. How do we do pop first? I think I can take many of things from my past code itself, so that's really nice. I would not have to worry much about implementation. Okay, okay, I can take a lot of code from my past implementations, right? So, and for implementing this thing, uh, we need non-elided but explicit lifetimes. So I would go with that. Uh, Now let's come to pop last, right? Mm-mm-mm. And as far as I remember, I even did pop last also. Yeah, that is here. I think I should have the position variant too because that is quite useful while writing many slice first year algorithms, right? So Yeah, I would take the example right here and pop last, and it should be 3, it should be 1 and 2, and I will need to say that where uh, whole is bidirectional collection, and again this thing should be whole, right? So that should be the case. uh yeah. Hmm. And this time I would not have multiple mute variants. I am actually thinking to have uh normal variant, but I don't know. mm, maybe, maybe not. uh okay, we'll see, right? uh yeah. Hmm. Okay. Let me have this variant of pop last with position and all those things. Yeah, it's so hard to do a good API design, right? Uh, you never know. Okay. Uh, pop last with position, uh, last position, and right, and even that was not right. Hmm. The last is still 3, but last position is 2, right? Hmm. So that goes for pop last with position. Yeah, writing talk is hard, but I think I have to formalize somehow slice and slice mute like what it should be, so that uh, I can propose it for Rust standard library going forward. Yeah. So this is kind of a little boring work right now, but I think it's an important one. Hmm. Okay. So I think that was uh, the thing, right? All of it, we did not have any of it, right? Okay, I did have pop first with position, if I'm correct. Mm-mm-mm. It should be there itself. Where is that? Yeah, this one. So I should have pop first right here. Uh, oh, what did I paste? Hmm. Mm-mm-mm. 1, 2, 3. Let me get the full slice here. Okay, I could not type full. Wow. First is basically dot. Mm-hmm. Okay, this is even just option. So I need to do an unwrap here. Wow, what I'm doing. Dot unwrap in the examples. Otherwise, examples would not work at all. Hmm. That's nice. Dot unwrap. Otherwise, it will not work. And yeah, first position is basically 0. Uh, first is first element is 1, and then we assert here r dot equals uh 2 3, right? And I think that was all the popping algorithms we had in the first place. And I would add some popping algorithms for lazy collections, the same popping algorithms for lazy collections, and then I would move forward, right? YAC, okay, GVP, uh, pop for lazy collection, right? And here you say it was a lazy collection. Oh my badness, this is so form next, and you do a compute it, right? And you basically return the element here, returns and removes the first uh, lazily computed first element. Okay, returns none otherwise. That seems nice. Lazy pop first, and this should be return removed. Nice. Hmm. Okay. First element, lazily computed first element returns none otherwise. Oh, this is not even a lazy collection. Wait, I need uh, a lazy collection here in the example, right? 1 to 3 is not a the array is not a lazy collection. Range is so. Yep. Anyways, uh, now for first, and we want to put a lazy here, right? Mm-mm-mm, right? And you return element here, and you do a compute at. Now the same thing goes for last, right? Mm-hmm. Hmm. and it might look like they're like so much code that is very similar, but these basic algorithm really helps to build very high level algorithms like splitting the collection, chunks, slides, uh, all those things. And even the parallel algorithms are really easy after we have a really good base of uh, working over sub collections, right? So that is why I am doing a good focus on sub collections. Uh, so how is it going? Element and yeah. What's the problem? Uh, 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 uh. For last, it should be computed, right? And okay, it should be lazy pop first, right? Returns removes and returns the position, removes and returns the lazily computed last element, returns none otherwise, and yeah, this is the last one. Hmm, hmm, hmm. Mm, 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 mm. Right. The only problem is this should be lazy. Okay, what's the problem here? Mismatched type. Yeah, because it needed a compute at. Right. So we are done for the lazy collection, and I think I would just go for a little formatting here. But yeah, now we are done with the lazy collection, I guess, right? So we can pop first, we can pop uh, last, and with position, and I think this is good enough for lazy collection, right? Uh, why? Because for others, you basically work with slices, right? And popping a slice or uh, doesn't matter it's lazy or not, right? So a slice is a slice. A sub collection is sub collection. It's when you get to element access, then you worry about that. Let me have some water. Nice. Yeah, we're on the right direction right now. Should I do something like this? You know. Mm-mm-mm. Okay, so now let's go and do things like prefix and all. Pop prefix or something. That is, I guess, even I have written that one. It's just that I named it trim, if I'm correct, right? YAP and right. I do not know where's that. There should be some trimming algorithms, right? So trim prefix up to. Hmm. Hmm. Paste it here. Trim the prefix of slice. Uh, pops the prefix up to given position, moves and returns the prefix slice up to slice to given position, right? And the best thing about this algorithm is all of this route backs to my uh, drop algorithms, right? So we pop prefix up to, right? Now I do have drop prefix up to, but what I can do is I can have similar things right here, right? Hmm. So, hmm. Oh, I did not. Why I do not have example for drop prefix up to? I do have example for. Is there some reason? Through. Wow, it should not have been the case, right? Up to and yeah. This. Oh, this works exactly same. Okay, because this is the thing. This is drop prefix, and we drop true elements, right? Uh, Now I do have drop prefix up to, so the same precondition right here, right? And mm, you have very similar example, right? Now the only thing is let prefix is pop prefix up to, and looks like this, right? Uh, this is how it looks like. Hmm. Okay. Nice. Similarly, I can go and have drop prefix through thing to pop prefix through, removes the prefix till and including position, given position, and returns, right? Hmm. Now for uh, doing pop prefix up to, pop prefix through, and again we return self, right? Hmm. Uh, how we do this is I also have implementation of this thing. Okay, so this is the from uh, Uh, right. And now I do have one more from, and goal is hmm, cannot move out of that. Uh, what's the problem? Unnecessary lead binding. Yes. Uh, that is. So this can be pop prefix through, and again the example goes like prefix is this one. This doc test is really helpful for me because I can just write test over as kind of documentation, and at least this gives me a kind of sanity check that yeah, you are doing quite okay, right? And then I can spend like little time on unit test, but it is not high priority because uh, while I'm documenting, I'm also kind of writing some sanities, so that's good for me. Yeah. So we have done pop prefix. What was that? So I should work with pop prefix version of it. This one, right? So removes and returns, right? And return the uh, full slice as result, right? Hmm. Now, right? So I got a new from. I needed old from. Um, hmm. Old from is self dot from dot clone, right? And we return a self where from is basically old from, and to is uh, self dot from dot clone. I'm seeing a way to avoid one copy in here, but I'm currently not that much worried, right? What's the problem here? Oh yeah, it does not need to be mutable. Yeah, that's true. So we have our pop prefix, and because the current state is I have like broken so many APIs. So if I would do a cargo test, it would not work because yeah, I was using the old names everywhere, right? But this is a very important refactor, and I'd be really excited when you know this would go through the Rust standard library, and this is going to be a Rion killer. So because this is the best way to write parallel algorithms and even the normal algorithms. So I think in upcoming January, I'm going to present this whole library in Adobe Rust Meetup. So yep, let's see how is the response at Adobe. I know two principal scientists at Adobe are really interested in this one, but yeah, I'm working with them, so maybe they're biased. Okay, we do have pop prefix. Uh, okay, we have pop while algorithm, right? Uh, so let's have this one. Hmm. Okay, so again, it's the same thing. You do a pop while. Let prefix is this one, and right. Oh, what did I wrote? What is happening? Yeah. Now, here is the mm, pop while thing, and it returns a self, right? So how do we do that? Yeah, like okay, let p is this thing, and yeah, let result is basically a slice where whole is nothing but self dot whole from is self dot from dot clone right now, and 2 is p, right? Clone and self dot from sp and return result, right? And this is pop while algorithm. Wow, it's a lot. It's a lot. Uh, I will have to say it's a lot. Yep. Now drop suffix from. Wow. Okay. Uh, let's put it right here. Uh, removes and returns suffix up to maximum specified length and returns the slice as suffix, right? 2 and 3. Wow. Pop suffix and we return self. I will have to put all of it to slice mute, but the good thing is now I'm seeing a structure around, so that is a good thing. Right. So how do we do that? Right. So we need let old from is equal to self dot from dot clone, right? And we return self where whole is nothing but self dot whole, and from is old from, and 2 is self dot from dot clone. Right, that's a classy way of doing this thing, right? So this is pop suffix, and similarly I want to do pop suffix from algorithm, and yeah, this should actually complete all my pop algorithms for at least slices, and I will have to think about slice mute, but that's totally fine. And then splitting would remain, but I am really fine with splitting. Like I'm really happy with splitting. Okay, drops and returns suffix from given position. Uh, okay, so here is this thing. Suffix equal 2 and 3. Is it even correct? Oh, oh I don't know if pop suffix is even correct. Wait. Uh, Even drop suffix is correct or not? It's not. Uh, yeah, it's actually not correct. What? Right? Because if max length is uh, greater than n, okay, I will have to think. I have to reason about this one. I have a collection like this one. I am not liking this song. Uh, yeah. Now let me think. Okay, and I have to do like let's say I have to drop 3 elements from here, right here. Okay, So what I do is it has 1, 2, 3, 4, 5, 6, 7. Let me put an indexes here: 0, 1, 2, 3, 4, 5, 6, right? So I'd be like, okay, 7 minus 3, right? It's 4 actually, right? And so plus 1, plus 2, plus 3, and plus 4. And that should be self dot 2. This is how it should be. So, hmm, okay. And if it's more than max length, right? What should the case? Uh, so I think it should be just 0. So, uh, hmm, and thus it should be simply self dot from dot clone, right? This is how it should be, and I will take this one. I'll put it like this. Okay. Now, uh, how we do this is let ol2 is equal to self dot 2 dot clone, and we return a self uh, where whole is basically where whole is basically uh, self dot whole thing, and from is old from is self dot 2 dot clone, and 2 is old2, right? So this is the way to do pop suffix. And similarly, I'm not sure if this one is right, but this one is actually right. So I would do the same thing. Let old 2 is self dot 2 dot clone, right? And old is nothing but hmm. What's the problem here? It should return self. Okay, and now we are quite done with our pop algorithms for slices. Wow. Uh, it was a big one, right? It was a big one. Nice. Uh, I think that was enough, right? Uh, yep. Pop while. Yeah. Now there comes this part. I will have to port this whole thing to mm, yeah, I will need to put uh, this thing uh, to slice mute. So let's do that. This is going to be a tough one again. So I had not touched the splitting algorithm right now, and but I would touch all the shrinking algorithms, right? Because yeah, I will have to see that is there any shrinking algorithm, lazy collection plus bidirectional collection, and there is this lazy collection plus this thing. Yeah, there are so many things I can just remove. Yeah, the shrinking algorithms. Yes. So yeah, I have this drop algorithms and yes, I would copy all of it here and what to say? Right? And none of it would work. I know that. Okay. Nice. I do not want to worry about the splitting algorithm right now, so I'd get rid of all of it. Hmm. Okay. All of this is fine. Now let's start. Drop algorithms. What's the problem here? Uh, okay. Here it should be a reorderable collection because uh, the mid-level slices need at least reordering, right? Now, uh, in here, I think, yeah, it's a lot, but what we need to do is we need to change this whole dot thing with full thing. Let's see. So drop algorithms got fixed. All of it got fixed. That's good. I would come and see why is this one failing. I think it should not. Okay. And again, for all of it, the example I have provided is with full. It should be full mute slash g, right? uh I think I do not have example for I will come to these things. I will come to that. uh yeah. Okay. So drop algorithms got fixed here. I think we need reorderable collection, right? And most of the pop algorithm would get fixed, right? Pop prefix. Yeah. Now these things would not be fixed. So for fixing this one, I will have to do uh, phantom is phantom data, and this would fix that, right? And we'll come to this one, pop suffix. This one plus reorderable collection. Okay. And I think almost everything got fixed. What's the problem for slice mute? So first position where I think it should we should be able to do that, right? Why is it not there? I do have a collection extension. So yeah. Okay. Pop first mute and pop last mute is not found in the struct, and that's fine. This is something we are missing right now, so we'll be doing that. But the good thing is we are done with the drop algorithms, right? Drop prefix, drop while, pop algorithms. Now, uh, pop first, right? And this one returns element. Bool is a mutable collection, right? And yeah, for the given lifetime A. So this is a very important thing. Like we return things for the lifetime A and not for the allied lifetime, and that's nice. Similarly, I have pop first. Oh, the first element mute, right? Right, and at mute. What's the problem? We do not have at mute? How is it that even possible? Uh, is it possible at mute? I do have at mute. I'm seeing it here. Hmm. Yeah, okay. Where wall is basically mutable collection, right? So now it would work. Yeah. Uh, and first full mute. So pop first mute, right? Mm-mm-mm. Okay. Mute, right? And then there comes pop last and uh, pop last with position mute. Oh my god, this is just too much of work. And then I have to think about the API names for uh, collections and splitting algorithms and other more algorithms, right? Okay, like I don't know, should I do like 30, 40 algorithms more? But let's see how it goes. So pop last, did I make copy of pop last? No. Okay. YAP, paste, right? Mm-hmm. All right. Hmm. And this should work. What's the problem here? Okay. FA, and this is a medieval thing, right? And now this should work. Um, pop last mute, and in the example also I need to call pop last mute. Okay. Why pop last mute with position? Okay. And you return element, right? How you do it? Mm-hmm. What's the problem? Yeah. It should be at mute, right? Still we have some problem. What's the problem? Yeah. It should be mutable collection. Okay. And we are done. So most of the algorithms are done that I was using, right? I think I was also using some trim algorithms, but let me remove that. Yeah, these were the trim algorithms, right? Uh, so I would remove that. I would remove that. Split at mute. Split after. I am really leaning towards the fact that uh, split algorithm should not have this mute variant. I'm leaning towards this fact. Currently, I would see split algorithms later, so I'm not uh, uh, thinking about it. But yeah, this naming and things are really important, right? Now, let me search the code base if I have this trim thing, and we have a lot. Trim prefix up to, and we have pop prefix up to now, right? Same goes here, right? Split evenly, exactly that thing, and we would see this, right? And even slices, I do have trim algorithms, so I would remove that, right? Hmm. Okay, and yeah, pop, uh, yeah, slice mute, it's removed, and that was all. So I think my project should be in a state right now that at least it should compile. Let me try. Okay, let's see. Yeah, it compiles, but some tests fail, and that is the best thing about uh, doc test. Hmm. So pop prefix up to. Mm-hmm. S dot equals. This is slice mute test, right? Uh, so up to two, right? Pop prefix up to two. So S dot, what it should be? It should be 1 comma 2 and 3 comma 4 comma 5. How was this thing working at all previously? Wow. What? Okay, there's so many things failing. Yeah, there are so many things failing. Uh, and I think these are doc tests. Okay, and x less than 2. Okay, Drop first. Line number 196. What's that? Okay, this test. This test fails. Wow. It should not. Mm, let's see. Uh, First position where predicate satisfies. Uh, so this is the drop while algorithm. This is a classic drop while algorithm. Uh, okay. Drop while x is less than 2. So drops the element of self. Mod e not of predicate comma e. Something like this. What's the problem? Right? Uh, Drop the elements of self till the first element self while uh, while the elements satisfy predicate given predicate. Yeah. And now this should work, but there should be a pop while algorithm. And it should have the same problem now. Right? And in the slice mute also, there should be drop while algorithm. And uh, in here, it uh, wow, it should have similar problems. Not of predicate of e, right? And there is pop while algorithm uh, with the same thing, right? It should be mutable, not of e, and that should work. So it fix some sort of tests there, and then I know why are other tests failing. So let's see. It fix some of the tests there. Yeah, nice. But we'll see what are the other things we are feeling. Oh, we are still feeling drop while. Wow. Okay, let me fix the other ones first, and then I will come back to drop while. Slice mute. Mm-mm-mm. Let ARR to let mute ARR, and that should fix a lot of tests. Okay. Seems like it did not. Wow. What's the problem? Okay. For drop while I got it. For left is right. Uh, Left is 3. All of it. Yeah. There are so many things failing. Man. What's going on? So we'll start. Uh, let's fix drop while first. Uh, Drop while, right? And pop while, and same goes for the slice mute thing. Yeah, I'm little bit worried about this duplication, but I think Dave said it's fine. So I also have to think about answering Lucian here, right? So Lucian tagged Sean, Dave, and me and told about how uh, positionless algorithms might not be an equivalent to STL, and I might want to do some mathematical proof, but yeah, in the last meeting, no, in the last to last meeting, I talked about min-max algorithm, and yeah, for the min-max algorithm, uh, he has some points. I think Sean and Dave are actually aligned with me, but I have a feeling that there are some things that is not possible with positionless algorithms, and because one of the things that Sean said here is I would approach a proof by taking the required operation on iterators and mapping them to pointless operations. The thing is, one of the operations is the positions itself, right? Because it's a position design, so one of the thing was positions were clonable there. It's not the case here, right? Hmm. But anyways, let's see. Uh, wow, what is happening? We'll see. What the hell? We are failing so many tests. Why? So let's go and check. Uh, so for slice, I'm feeling like lazy pop first with position, pop first with position, pop prefix through. All of it is feeling right. So let's go and check what's happening right there. Right. So 381 and uh let cannot be used for global variables. What's the problem? Uh, okay, this is pop prefix, right? But I have used let a lot, like a lot, for other docs. So if I go for, let's say, something like uh, collection extension. So here I have used let. What's the problem? Font keyword let expected item. There should be something that I'm missing. Okay, let's start with let cannot be used for global variables. Not a fully short according to one previous error. What? Static. Let's see. So pop prefix should go. So pop prefix, no, it did not. Right? It did not. Pop while, pop suffix. What's the problem? Pop. No, there is some different problem. I'm not getting what's the problem. Uh, is it just because of I have written example and not examples? That should not be the case. Pop prefix. Wow, I'm not sure what's happening here, but its straight bounds were not satisfied. For lazy ones, let me fix the lazy ones. Mm-hmm. So I see we do have lazy pop first. So this should be okay. Now let's see what's there. Cannot be dereferenced. Oh, what? Wait. What's the problem? Integer cannot be dereferenced. Okay, fine. Hmm. Oh my goodness. This. What's the problem now? Okay. Integers 3. Where is that? Okay, somehow. Wait. The resource utilization of my PC is going not too high. I don't know why. What the hell is going on? Okay. Hmm. Wow. Uh, what's the problem? I'm not even getting what's the problem. Uh, right. If I go to collection, extension, map, it takes self and returns the same thing. I am doing exactly right. I'm not getting what's the problem here. Uh, okay. If that is the case, then I would just write test. Mm, and we'll see what's the problem. My test, right? Hmm. What is S? What is ARR? Oh, okay. Fine. Here is the thing. This map thing is not my map, right? This my map thing is not my map, or it is it? Yeah, it's not my map. So, hmm, collection extension map. That is why I'm saying that Rust standard library is broken. Like they do not think about generic programming. They are very away from footsteps of Steppenov, and yeah, I will need to fix that. Not this one, not this way. Yeah. Oh my goodness. Yeah. Uh, Now let's see. Still, we fail a lot. Uh, a really lot. But this time, we do not have any uh, error like the one we were having earlier. Mm. Okay, nice. Uh, so lazy collection thing is fixed. Now I need to see the doc test of why these things are failing. Because expected item. Okay, fine. So is there some problem with this test? Let me do that again, the same experiment. Uh, so array test, right? Not this way. Oh, it does not go as I think about it, right? Okay, makes sense. We are missing asserts. Now, these tests are fine. Okay, we are missing asserts. So let's do this. Uh, so yes, slice. Left is 3, right is 2. What is this one? Hmm. This is line number lazy pop first with position. Left is 3 and right is 2. I'm not seeing the right. Where is right 2? Okay. Uh, so here this one, this one, this one, this one. Mm-mm. Okay, am I done with all of asserts or not? I think I am. So let's see. Okay. I don't know if yeah, now very less amount of things are failing, but that's totally fine. Drop while is still failing. Okay, that's fine. I will see. Let me first fix this for slice mute 2. Right, right. So the semicolon thing really hurts, right? And when you are writing doc tests, for sure it hurts because you do not get LSP suggestions there. Okay. Hmm. Nice. And now really less amount of things are failing. So we are making progress. We are making progress. Okay. Let's see. The first thing that is failing here is lazy pop first with position. And assertion that field was it's 2 3. Okay, let's see. Oh wow. You don't show me the line number? Line 581. Fine. Line 581. Hmm. So what's going on here? assertion equals to 3. Okay. Uh, okay. The first position is actually 1 here, and the rest is 2, 3. So that seems to be fine to me. Lazy pop last. I guess I got the positions wrong because here the positions are exactly same as the elements for the ranges, right? So let's see. Yeah, we're feeling some of it. Mm-mm-mm. And still you're feeling lazy pop first week position, right? What's the problem? Hmm. Okay. Okay, this should be S, right? This should be S. Lazy pop last. How did I do ARR there? I'm not sure. Okay. Pop first with position, and here also it's S. So yeah. Then I think drop while would be the one remaining. I am not sure what is the problem with drop while, but let's see. And then we can fix similar things in uh, midwell slice mute thing. Yeah. So what's the problem with drop while? Why it is failing? Assertion fails 2 3. What's the problem? So we drop while it's less than 2. So we drop 0 because 0 is less than 2, 1 and 1 is less than 2. So S should be equal to 3. I'm not getting why is this assertion failing. I'm not seeing any reason. Is it something like this thing? Because I did a not on an integer? Oh, is that the case? No, that is not the case. That's fine. Okay, fine. What I do is I would print a dot for each mod x print, right? And yeah, cargo test. What's s actually? Will it print that in? It's 0, 1, 2, 3. Oh wait, what? It did not drop anything. What? Uh, because okay, I think this is because we do have a drop while algorithm in. Okay, yeah. Uh, so here is the problem. Collection extension, and this algorithm is totally fine. This is just because of this drop while thing. So we do have this drop while algorithm right now with us, and yeah, currently I would just name it drop while underscore, and we'll see what we can do with this drop while algorithm, because I am not sure what to do with this drop while. I think I know what to do with this drop while. Drop while this. Okay, collection extension drop while, and I would name it dropped while. Right. So there should be some more drop algorithms, right? So let's see. This is the Swift API conventions I'm following. I know it's Rust, but I think Swift API guidelines are really, really nice, and everyone should look into it if they are programming. Okay. Yeah. How many places I use this? I searched it. Literally, I searched it. Oh man, yeah, lot of things are failing. Drop and drop in mute. What is that? Okay, it's good enough time. I'm quite exhausted now. Okay, I will take a break. Oh, what the hell? Hmm. Dropped in mute. Okay, I think they should solve the algorithms one, and we'll get back again to the slices thing. Oh, it did not. Wow. 168. 168. What's the problem? Yeah, this was. I think I need a break. Uh, at least a water break now. How much did I stream? Like, how much? I think I streamed for a while now, right? 2 hours 36 minutes. It's a good enough, right? Now again we are back to yeah, slash.rs and line one number 196. What's the problem with line number 196? Line number 196. No. Slash.rs line number 196. Not full. Okay. Hmm. Now I will have to think about this dropped algorithms and things, but uh, yeah. What the hell? Why is not working? What's the problem? Okay, it's not that. It's slice mute. Oh, it feels so nice to see this. Hmm. And uh, what's the problem here? Pop position with line number 718. Yeah, the position is 1. Last is 3. Pop. Uh, Last position should be 3. Okay, it should be 2 only. Okay, wait. All of this was fine. What's the problem? Oh, wait. So the last position should be 2 only here, right? Uh, in here where I changed this one, the first position should be 0 only. So what's the problem? Let's see. It's saying that ARR equals, okay, it should not be ARR, it should be S. Okay, first with first with position S for first with position and S. And now everything should work. Oh man, the project should compile, it should work as intended. Yeah, now it works. Uh, yeah, we will have to think little about this pop algorithms in collection so that I can push the whole thing, right? So let me think about that. Uh, 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 See if that is not a standard or does not exist. Mm-hmm. For first, okay. So what I want to say is, okay, collection drop while. So dot trim prefix drop. So I'm not sure. Let me ask ChatGPT about naming. Mm, okay. Common naming discussion. Prepare circles. Use noun verb. Drop returns new collection with first element. It does not mutate the original one. It's a transformation. It's not ranking. So many you add property like name rather than verb like name. That's your instant word dropped first. Makes sense. The guideline. In fact, Swift has precedent there for analogy, which sound like a command, but doesn't. But uh, give me link to some forums where this has been actually pointed out. Hmm. We dropping first. Wow, Dave Abrahams is here. This is going to be a really good read. This is going to be a really good read. I'd be doing that, and based on that, I'd be deciding the things. Anyways, I'm taking a break for a while, like timer for let's say 5 minutes, and then I'd come back and see. Okay, back guys, back. Yeah, following the new API guidelines shouldn't. Okay, I need water too. Wait, I need water too. So I take one more 5 minutes break. I'm back. Hmm. Okay. Meditating method is described. Really, the convention is that when a meditating method is described by a verb name, its non-meditating counterpart by telling me that no one bothered yet writing meditating version of this method. Uh, the ing style rule does not apply. That the first two rules glanced ahead. At part of one for non-meditating version. Seems I'm not familiar enough to Russian Haskell. I began uh moving, moving. Rust does use take. It actually does not use drop, but instead use skip. Which something like that, but I to name it. I'm tempted to say that we use take instead of prefix. Because it's not immediately obvious, but it does. Drop lash. Use it for describing all these operations as discussed in this thread. Okay. Oh, what's this? What? Why did Dave? What is Dave doing there? I don't know what is this. Hmm. Mm-hmm. Okay, I am not seeing. I think instead of dropped first, we are thinking regarding dropping first and drop last. Yeah, like dropping last. This is what I'm thinking. This is what I'm seeing. Hmm. So I would go and follow this one collection extension. So dropping while right? Dropping suffix. What is that lakusaku thing? What is that? Uh, dropping, dropping first, dropping, dropping, dropping while. I think this is a naming convention. That is nice. Mm-mm-mm. Let's go. What? Okay. Mute. Okay. This is good. Okay. Wow. Really big commit, man. Really big commit. Okay. Fine. I am creating a PR. Let's see how it goes. So there is lot of change, man. Lot of change. If you think about it, it's like it's too much. Okay. Ha, ha, ha. Yeah, these things are working. So I can now push because uh, should I think a little more? I think I think split algorithms are there, but we'll see. We'll see. I'll push it. Anyways, so fixed slice algorithms. Now uh, we do have these algorithms right here. Right now, I can try to use these algorithms to implement other algorithms. Right. So let me try to do that. Okay. So for example, O plus. What? What? Oh man. Okay. Uh, shoot. Shoot, shoot, shoot. We do not need collection here. I should have run the cargo test before pushing, but yeah, I was ignorant. Should I turn on screen key? Because sometimes it's fun to watch, right? Uh, nice. Slice mute, right? So, hmm, hmm, hmm. This is lazy collection. Okay. So now we need to see the splitting algorithm. We have to think about the splitting algorithm. But before that, I want to show that all of this work on slice is actually really helpful. So let me go to collection extension, right? And here what I can do is I can just call self dot full dot pop first, and that should work. Or no? What's the problem? Found. Oh, what? Type parameter. What? Uh, oh, there was some reason. Self as collection. Wait, I am doing something wrong. Let me see it later. Let me start with prefix. So what is prefix? So it's like self dot full dot pop prefix of max length. Let me see if it works. Right? Somehow memory usage is too high, like too high. I'm not getting why. Uh, okay. Due to this one memory usage is high? I don't know. Okay. So prefix up to. It's fine here. These are some small things, so I'm not worrying. Dropping prefix. So I have to do calculation. So dot uh, s dot. Right. I can change the algorithms like this. Similarly, dropping suffix s dot drop suffix and s, right? Hmm. Now suffix again dot full dot uh, pop pop suffix, and this is how we can write most of the algorithms, right? That go and do things with prefix and suffix, and all of this should work. Let's see if it works. It works, right? Similarly for if I go for reorderable collections, right? Hmm. So in here again, what I can say is, let's say I need to do this prefix mute, right? So what I do is self dot full mute dot uh, uh, prefix of max length, right? Okay, pop prefix of max length, right? This one looks nice. This one is also quite okay. This one is also quite okay. Uh, Dropping again, this algorithm is something we are doing some sort of calculation. So what I can do is let s is self dot full, and we can return s and s dot drop suffix, right? And should be mutable. And yeah, this way of doing things actually just helps a lot. But my point is, the way it is written right now is also really good, because we do not create object and then do clones. So I'm quite happy with the way it is right now. So I would not accept these changes, right? Uh, because uh, it would be just a creation of additional objects. It might be optimized by compiler, but I want it to be first by definition. And I think uh, in a standard library, because this project is intended to be the future of Rust standard library, so some duplication is fine for good performance. Anyways, okay. So last thing remaining for the stream is thinking about split algorithms, right? Uh, that how I should think about split algorithms. So currently I have split algorithms for slices. So here you see I have the split algorithms here, right? Split at and split after algorithm. Now, one thing is, uh, should there be split algorithms for uh, collections in general, right? And I think there should be. Uh, it's fine to have that, but yeah, we have to think. But because these are verbs, right? So that's good. Hmm. So I think There are two things I am worried about. One thing I am worried about is uh, slice mute, and here we do have split at and split at mute algorithm. So I'm quite worried about do we need this underscore mute variant? Like what I think is if I'm splitting a medieval slice, right? This is simply uh, this is simply uh, some sort of simple split, right? This is the split. If it's a medieval slice and I split it into two, there should be no way it becomes immutable slice, right? Unless we project it immutably. So I have this feeling that it's just we should think about split at algorithm, right? And are we using split after algorithm? Split after. Are we using this? I don't think we are using split after algorithm. So, but it's fine to have a split after algorithm. I've not. So here's a decision I'm taking, and it might be wrong decision, but uh, I am going to take this decision, and that is splitting mutable collection would only give you mutable slices. Mutable slice splitting mutable slice would only give you mutable slice. So this is my decision, right? This is going to be my decision. It might be a fully wrong decision, but I feel this is kind of correct decision to have, right? Uh, I'd make some examples here so that people can understand what is this thing. Uh, so why I write this doc is a really nice thing, right? If I go and see my rs-stl repo, right? Uh, I have this documentation that I'm writing as comments hosted there, right? And everything I'm writing here uh, are there basically. So you see drop last, drop prefix, and everything is there as example, right? So that is the best thing. Uh, Writing this as documentation because you get really a lot of things, like really a lot. Anyways, let r is 0, 1, 2, 3, 4, and arr dot full dot split after 2. So because we split after 2, let s1 s2 is this one. So we assert that s1 dot equals 0, 1, 2 and s2 equals 3, 4, right? And I can use similar things for documenting this one, right? but here I am like split at this point, right? And when I split at this point, this is how a split looks like, right? So yeah, the same documentation. It's just that this time it's full mute, right? It's again full mute array. Okay, so this is there. Now I think I have slice mute test and split after is gone, split add is gone, and in here this is how tf this split after, right? What's the problem? This parameter might not be properly closed. Okay, yeah. And we do a cargo test. Hmm. So this passed uh, slices of the type can only be divided into uh, that type, right? Okay, now I think for collection extension we do have some slice algorithms. So the splitting algorithm is something we should be writing right here. If I go, I say, so I can just take all of this algorithm, split uh, provides to uh, how it should look like. Mm, so let me first write the doc for it. Uh, so arr dot splitting at 2, right? And you return slice of right. So return this thing. Hmm. And now you're like, okay, self dot full dot split at position, and this is how we do it, right? What's the problem? Visibility qualifier is not needed, so that's fine. Now the same goes for split after, right? Hmm. So it should be by Swift API guidelines, it should be splitting after, right? And it should be self position, and it should be like slice of uh, self wall, right? And what we do is we do self dot full dot split after position, right? This is how we do this. And I do want to generate some summary for this one, but before that, yeah, I might want to generate some summary, like a good chat GPT summary, so that I can just paste it here and I do not have to think about English for the time being, right? So for us rs-stl, I am writing uh, splitting algorithms. It's there in slice right now. However, I also want to provide it for collections in general, like this. Please write a good summary for both methods, right? Ah, yeah, returns two different slices of self-splitting at given position. Yes, this is one, right? Anyway, so yeah, this way I can. Currently, I'm not worrying about panic at all. Like, if it panics, let it panic, right? Because usually it panics when you try to do un some operation that is out of precondition, and usually that is a bug. So I'm really not worrying about panic. Correct your logic. It would panic. Anyways, yeah. I think the similar summary I would like to have for slice mute. So split at algorithm, right? And I can just use that to rejoin mutable slices, and to disjoint mutable slices, the split after the given position, right? Hmm. And At last, I'd go for reorderable collection, and I have the slice algorithms here, right? Now, collection extension, I can just go and copy this one like that. Okay, nice. Return to disjoint mutable slices, right? And full mute, split after this thing. Oh, the documentation is quite wrong. Error dot splitting after mute 2, right? Hmm. Right? This one is now nice. Splitting after mute. Okay. I guess here the documentation was also not the right thing. Splitting after, right? Splitting after this thing, and now we are yeah, now we are good. I think everything should work, and yeah, I mean, I'm quite exhausted. No. Okay. Yo, it should be mutable because okay, this is the BGM I use when I put my status with Sean and Dave, and we are quite done, guys. We are quite done. Add uh splitting algorithms for collections, and now we have almost every algorithm present to work, right? We have a really good amount of algorithms for computing prefix, computing uh, slices, computing different things, and yeah, that's actually nice. We will use all of it. We will use all of it, right? This is the beauty of slices, right? Uh, so I don't know. Split mute, slice mute. Sorry, it's like 1,000 lines of code. Are you seeing this? It's 1,000 lines of code, and yeah, you sometimes need to write this much code for a data structure like because Stepanov said, more the algorithms, better you know the situation. So yeah, we are writing more and more and more algorithms possible, And for today, I'm done. I think I've written so many algorithms than yeah, I was expecting. But the good thing is the situation of the slicing, prefixing, iterating is now fixed, and I think we are at a really good base for rs-stl, and that is so nice, right? Because now I can take, you know, rs-stl, and I have a good base, and I can develop higher level algorithms like sorting, uh, like windowing, like chunking, like sliding, like striding, joining, so many things, right? Uh, so yeah, I think we are at a really good base, and of course, parallel algorithms. I have to see parallel algorithms. The goal is to replace Rayon from REST ecosystem. I think Rayon is a really complex but good thing for parallel algorithms, but I think I have even better one, right? I have some fundamental things about collections, and this fundamental things would help to write parallel algorithms in a way better way, right? So yeah, that's it. This is all I had for today, and yeah, I would be ending stream. Let's see if someone is there on the stream. I'm not sure. Yeah, I am seeing at least few people joined. I do not know if someone wanna chat, but I think it's a good stat, right? At least some people joined. So yeah, that's good. Uh, if there is nothing on chat, then I can actually end the stream. And yeah, it was a productive day today. Uh, I have been streaming for 3 hours and 45 minutes, so now it's just too much for me. But yeah, it's a good amount of work I did. So, yep. Uh, thank you, everyone, and let's see what we would do for the next stream. Next stream, I think I'll be doing some parallel algorithms now. I will think about parallel algorithms. I would think about uh, sorting algorithms and like that. But yeah, I have to increase algorithms a lot. Before December, I have to make the count of algorithms uh, to an extent that I can use it at advent of code without any problems, right? Because I have to show that this model is really the one that suits for advent of code. So let's see how it goes. Anyways, yeah, that was all from my side. And thank you anyone who joined, or if they enjoyed or not. But yeah.